Hey, how's it going? Live. So, just a quick note, okay? Oh, I showed you the other day, actually yesterday now that I think about it, this little code folding tactic, let's call it that I discovered. And so we were looking at a particular function in here, so that's PCC, all right? So this is a fairly simple function. It's just making some calls to a filter. So it's sort of like a preprocessor for Perl call. Okay. So anyhow, I'm just chose this function because it's small enough, so I can test things with it, and it has a little bit of everything. So yeah. And I have here some experimental way of breaking that code folding, utilizing it to build a parse. Okay. So what I'm gonna do is I'm just going to show you like the basic tree, okay? So without going recursive, all right? So let's try that. And as you can see, it sort of hides like a lot of information, right? So here for the first if, so we have the condition, but it's abstracted away behind this cut, okay? And likewise, the block is abstracted away. But we have enough information to determine this is an if statement, and so we can say whenever we want to expand this, we can expand this, right? So it's a good way to try and sort of help the computer understand what the code is doing, in a sense. Actually, let me just show you before we go recursive, okay? Let me just print out the block as it is, okay? So you can have some finer appreciation of what's going on here, okay? So if we print that out, you see this is sort of like the raw string that we're taking, right? So this is from reading the entire file, then processing it to regexes, and using that to find the blocks of code belonging to every subroutine. And for every subroutine, we do know its name and all of that. So here I'm just picking the ID PCC at random, but I could take the make, which is another subroutine, and it will give me the code for that one, right? So we've parsed the entire file and gotten these blocks, right? And every cut, every of these cut tokens, basically represents a section of the string, but abstracted away. Okay, so that's basically that. It's not very complex. And yeah, from the block we can find some more information. I can actually show you. So it's code fold, okay. I need to go actually down here. Okay, so we have the name of the block itself, so the name of the subroutine. If we use any subroutine attributes, we can also get that. We can get the list of arguments, nice things. And then in here in the strings, what we have is it's a container for the cut tokens, right? So this exact string, this cut token, will be used as a key into that hash, and that will give us the expanded code. And then what we do is we just recursively, if we recurse, we expand those blocks into the code, and then we process that a little. We remove comments and unnecessary white space and things like that. This is basically what this function right here is doing. So it's just it sanitizes the string, so to speak, and then it tokenizes the expanded string. If we do this recursively, we wind up with a tree. Okay, so there's a little bit of a couple tricks here and there, um, but you know my node class is actually kind of long, so you know I can show you like at a glance. Okay, so yeah, this is it is pretty long, but it's not that complex actually. It's a lot of code. That's just what. So yeah, I think I have a bit of a reputation for saying that that things are not all that complex, but yeah. So anyhow, I'm gonna show you again the base tree, let's say, and here's that, and now if we recurse once, what will happen is these blocks in here will be expanded further, okay? And so we're going to do a single recursion, and let's try that. And as you can see, now we have more of the code, but we still have some of these. And actually, this is a little bit of a strange bug. I can fix it actually, but the thing is that uh, $sign and colon actually is a variable. So that's actually unfortunate, quite unfortunate actually. Um, but actually I can fix that because I'm not using that variable. I don't even know what it's doing, and quite honestly it shouldn't be there in the first place. So yeah, we should be using the English module for this kind of thing. You know, like instead of doing this we want to do this generally, um, because then it's not quite clear what the code is doing. You know, unless you're into golfing or you want to obfuscate the code, it really doesn't serve like a good purpose. At least I think that readable is better. Anyhow, if we take that out and actually have to rebuild in order to do that, but that's fine. Okay, so it has to run twice because of a I'd say. Oh no, actually it just run once. Right, so it's just right, so it's doing like an initial update, and then it's right. So it's building the core modules first, and then it's going to everything else. So yeah. Okay. Right. So it would have to build twice if I was bootstrapping it. In that case it would have to build twice. Yeah. Okay. So anyhow, let's try this again, and let's see if that pesky bug is fixed. So let me just see if I can find it. Okay, so apparently no. And here's a strange thing. Apparently, one level of one call to recurse was enough to actually expand the entire tree, which was not what I had in mind. But well, this is experimental after all. Anyhow, okay, so actually I don't need to do this, so that's kind of nice. Okay, so if we recurse, we expand the whole tree. So pretty cool. Uh, there are some bugs, obviously. In here, I think not this part here, but some assignments don't work. They don't work right. So here you see the condition for the if statement expanded right, and so did the block, right? And it's actually kind of cool because you know, it put everything, you know, under the curly brace, but not quite right. You know? So this block as well should be inside of the curly, and it's not. So that's not so nice, right? But actually, I think I can fix this. What I should do actually is I should, when splitting, right here in the expand, what we should do is instead of splitting by, oh no, wait, excuse me, so it's not there. Here, what we should do is instead of just splitting at semicolons, what we should do is Give me a sec. I'm gonna do it like this. What we should do is expand at right, so at opening and closing braces, but the problem is I should capture that, right? So this semicolon, well, actually, maybe I do want to capture that, don't I? Oh well, what the hell? Let's just do it. Why not? Well, for now I'm not gonna. Okay, so just thinking out loud. Sorry. So if I do that, oh no, I do have to capture that. If I do it like that, oh. Oh, 72. What? Right, so that's kind of strange. That does not make a whole lot of sense. I mean, this is not read-only. I'm sure of it. So what happened there? All right, so this is unexpected. This is actually very much unexpected. Okay. Okay, I'm game. All right, let's try this. We're just going to skip this and just get the list of tokens, okay? Oh, but I actually do have to expand, so no. What I'm gonna have to do... Can I try catch? I think I can, but I don't quite remember how it works. I'm just gonna do it the old-fashioned way, okay? You know, when in doubt, caveman debugging. You know, it's simpler to do it this way. Right, so capture that. Okay, so I'm not going to try and print this. All right. Well, so that does not make a whole lot of sense either. I mean, holy. Well. I was pretty sure that this was clean enough that it wouldn't give me that result, but well, would you look at that infinite recursion? Would you look at that infinite recursion? My favorite. All right, so right, because I'm going recursive and trying to split at the curlies, and in doing so, there's always a new curly to split. So right, that's that's not what we want. But kind of crazy. Actually, kind of crazy. You know, I never managed to collect all the pieces of the Staff of Chaos. That's just my confession for today. I played Arena a whole bunch. More so than Daggerfall. I think not more so than Oblivion, because I played Oblivion a lot. And Skyrim, I played Skyrim a lot. But you know, I have a really soft spot for Arena. It's like, yeah, I would tell you it is, you know, like, I'm just gonna lean back like this. It's my favorite title in the series, you know. Like, yeah, you know, like people that say Morrowind is their favorite, like, yeah, I get it, Morrowind is a great game, right? But dude, like, seriously, I mean, I find the combat in Arena more thrilling than the combat in Morrowind. Honest. Like, yeah, I get it. You know, if you can get over the combat, it's one hell of a game. But and you have those spells the size of nukes. That's the, yeah, that alone makes it a great game, right? So you can just cheat your way into mass destruction. So that alone is pretty cool. But yeah, the animation is so dull. It's so incredibly dull. And you know, to be fair, the animation in Arena is also pretty fucking dull, but because it's like, you know, it's like this size, you know, it's like this size in resolution, you don't really, you know, it can be, it's something that can be excused, right? Um, in Morrowind, you have no excuse for how terrible the animations are, you know, like I can make a smoother walk with 6 frames. I'm serious. Give me 6 frames of animation. I'll give you a better walk and run. Seriously, right? I'll do it someday, okay? Hold me to that promise. Yeah. The animation in Morrowind is just incredibly lazy. Everything else is fine, but the animation is, yeah, I don't like it. You know, it doesn't make me feel good. But yeah, on every other respect, yeah, absolutely great game. Alright, so I want to I'll try and see if I can find a good solution to this. Well, I guess that what we can do is do the, you know, and this is a hack, okay? So, yeah, it's just not really what I should do. I should probably I should probably work this out from the loop itself. But, what the hell? Let's just do it my way, okay? So what I would like to do is basically take this splitting, taking the curlies, and just make them their own expression. Because if we do get to that point, so because the thing is, if we only have one token, this will early exit because it will assume there is nothing to tokenize. This is already a single token, right? And so if we have a captcha in our split, yeah, that's not going to work. We're going to have always more than one token. If the single token that we have happens to be one of the ones designated for captcha. Huh. Wait a second. Right, it's in the logs. wait. I have a better way to do this. I have a much better way to do this. Okay, so what we have to do actually is we have to filter this out. Nice. So sold basically. Actually, let's do it like this. Let's say temp, and then we're going to have exps. Okay, this is going to be empty, and so for actually, let's do it in its own scope. Just just because I don't like taking up the namespace with temporal. So for my let's say just say s in temp. If I'm just going to use a strip line in here. So if not length of strip line, and strip line will just tell us how many non-white space characters we have. And oh, actually, I'm gonna do it the other way around. If we have non-white space characters and it's defined, it's just yeah, everyone gives me crap because I format the conditionals like this. It's easier for me to read. People just get over it. So this is quite a lot of indentation. This is like a Hadouken, This is just straight up Hadoukens, man. But what you wanna do? Okay. I suppose I could do this with a map, but it's not so fun. Well, if we do achieve it to get here, we just want to push, right? So this will be our filter, right? Now, will this work? Let's find out. Okay. Let's just let it rip, and no infinite recursion. Here we go, baby. There we go. Okay, so that's fixed. We can remove this print now. Okay. And let me just remove that. And it works, apparently. Yeah, I'm going to assume that was not a problem. And let's just preach. Okay. So. All right, so we still have some problems in here with the assignments, right? So, and in here with the module names. So, right, we do have to work this out. I'll do that later on, but right, and so in here you can see, well, so it was not the fault of the curlies, but well, anyhow. As you can see, some of the assignments, for some reason, they are lost. I would suppose... Oops. Let me see, it's log. Yeah. Right. I know why this happens. Because the tokenizer doesn't really know how to deal with this character because I haven't told it that that these strings are a thing. I guess I could. There is one thing I can try. I could just say. Actually, I'm gonna have to edit the node class for this, so brace yourselves. All right. So I guess what I could do is just have a whatever class, right? So just say if it doesn't fit into any of this, just get the whole get the entire thing, and that's a wrap. Okay. All right. So let's see. Still nothing. Oh, right, because I have to I have to rebuild for that to work. Right. Okay. So. Okay. Let's see. There we go. Okay. All right. So this is not a full fix, but it's good enough for now. All right. So, am I parsing Perl code? Not really. Not really, but we're trying, right? So yeah. For the most part, this is so that we can have a metadata about our code. This is not so much in order to execute Perl code, right? So the purpose here is not to parse Perl in order to execute Perl, okay? We're not going to do that. The objective here is to have a good way to parse Perl files in order to modify them, okay? So this is what I'm doing with this builder, with this project builder. For the most part, what it's doing, it's inlining functions, and I have this thing that it's getting updated every now and then. It's this thing here, which is a list of certain functions I use that are inline, right? And these are for the lang module. Okay, so basically what this is a list of it's a list for symbol metadata, right? So for subroutine metadata, right? So the idea here is that this is all the information, generally all the information you would need to inline a short subroutine. But taking it beyond just inlining, we can do some analysis of our code in order to, I don't know, to facilitate certain tasks, or for having a better interface for object-oriented that isn't Moose, because Moose actually sucks. I'm sorry, but it sucks. It's not good. I don't like it. If you like Moose, that's fine. If it's like like your favorite object-oriented framework, that's okay, right? So that's cool. You can use Moose all you want. I think it sucks, and I'm not gonna use it. So yeah, I need my own thing, and what my own thing is gonna do is actually it's gonna beat everyone else's performance benchmark, because I'm going to inline the getters and setters, right? It's like, you can't get subroutine overhead if you never call the subroutine, right? So yeah, that's what we do over here. So yeah, okay. So anyhow, this is still experimental, still a work in progress, but we can go somewhere from here, right? So we can already make lists of how do you say? We can already make lists of our variables, because we can find. Actually, let me show you. This is actually pretty fucking cool. So let me close this and this one as well. So what I'm gonna do is I'm gonna utilize a little method from my node class, which is branches in. Okay. So what does this do? It looks at your tree and gives you every branch that has a given value. Okay, so branches in would be anything that is a child of a branch that matches the pattern. And then branches with would be a collection of every branch that has a certain leaf that matches the value. Okay, so let's just try that, and it's gonna be my. All right, and I want my all. Okay, so for my branch in R, we're just gonna say branch breach. We're gonna print out. We're gonna breach out the branch. Okay, so let's try that. All right, and so you see, we do this, and this one is actually broken. We'll have to see what's up with that. But you see, we can get immediately a list of all the variables, and so we have a filter, suppose, and we want to do something with our lexicals decorations. We can just grab that from the tree. So kind of nice, right? Kind of nice. And so yeah, I think that's pretty much it. I have to do some optimizations for this because once you recurse, it's all hell breaks loose, right? I can probably handle that somehow. I can probably handle that. I mean, actually, this one should already be compile regex, so I shouldn't have to mess with that. Now this one I cannot redo, and oh, give me a second. All right, so there's one thing I can do, and this is taken from the hacks in my library, right? So yeah, I can inline functions without having to build. It's just going to be slightly slower, like the first time I run it. But yeah, we can do that. So now basically every function I have from lang that's marked as inlined will be inlined, right? So what do you know? So the main culprit is usually this one, right? Because in a deep enough recursion, this could be called upwards of tens, hundreds of thousands of times, and it's not what's happening right now. It shouldn't be over 100 or 1,000, but yeah, subroutine overhead, it's a thing. So yeah, we don't want that. So yeah, that should give us a slight speed up. And another thing we can do, we can compile some of these regular expressions. So let's do that actually. So let's say, actually I can put that into, which one was it? I think it's style. Yeah, I have, yeah. Let's just do new line re. So this is like, things that are common enough that I would like to have them everywhere, right? So yeah, let's just do that. New line re, and what else? Like, I didn't know for the longest time that I could compile reexes, or that quote unquote compile, right? But but basically that you can make regular expressions that are possibly compiled and will oftentimes run much faster. So yeah, that's kind of what I want. And this one is nasty. How let's say x boundary. something like that. Yeah, it's a work in progress name, right? It's a working name. We'll change it if we have to. Okay. I'm gonna use the X just to separate this a little, but it's not so hard to read, right? And I guess actually there's no point to using a character class. I can just keep it like this. So yeah, this is still hard to read. It's a regular expression, right? But it's not so terrible. Ugh, now let's just put it. Let's just do it like this. Okay. And add some spaces for clarity. Yeah, that's it's a little bit better, no? Yeah. Okay. So that's compiled. Let's see what else. Well, I don't know if it's compiled. Possibly it's compiled. Okay. Hmm. So here I could try using this rather than the capture itself, because why would I do that? Then just use it like that, and that should be slightly bit faster. Okay. Another thing, and for this we need to go into the node class. All of these things I'm declaring here, I could take them outside the function, and that could maybe be a little bit faster, but I'm not entirely sure. Alright, so what I'm gonna do, I'm just gonna compile the ones that I use within the while, because those are, you know, the ones that I'll be called more frequently. So let's say a token re. Oh, no. Oh, oh, okay, that doesn't make sense. I can put this here actually. All right. Okay, so I don't have to do anything. Nice. Okay, so let's just make this beginning of string. Well, it will be a beginning of line, but yeah, in this case, I know for certain that's the beginning of string, so no problem. Just do token re. And okay. So I guess I could compile this one as well. Eh, let's do it. So this bit unnecessary actually, I'm pretty sure. So say my white space re equals qr all of this, and let's just white space re. Okay. So that might be, you know, it's still gonna be a little bit slow, but it might be a little bit better. Okay, let's try it. Okay, here we go. All right, so where is that print? So 462, and it didn't like that. All right, so just can do it with an O. Okay. REPL. REPL. Oh, I know. Now I know. Okay, give me a second. 129. Right, because I do need a capture here. I do need a capture here. Let me check. Token re. Okay, so this one is non-capturing, so I'm kind of screwed. No problem. We'll just have to deal with this. So let's capture, okay? Because right. Okay, what you're gonna do? So the so the problem here is I can't just use this expression in order to fetch the string, right? So I need the exact name. In order to get the exact name, I do need to, how do you say? I do need the, oh, I can't, my brain is freezing. I do need the exact token in order to fetch it, right? So just the pattern is not good enough. So I do have to take the capture here. That will be capture 0. And I'm gonna say that's my key, okay? Yeah, that should be, actually I don't have to redeclare key, so nice. Okay, so let's take key. Let's take the string at key, let's say. And let's try that. All right, nice. So I don't know where this printing is coming from, but likely somewhere within inline. Oh, it's actually from shell. So that's hex shell PM. So sub get L. So it must be somewhere around here. Nope. So it must be inline. Okay. All right. There we go. So I was debugging apparently. Okay. All right. So, but we get nothing. So that's not good. So what's this? Okay. Branch preach. Okay. It's not finding any such branches. That's weird. Oh, it's not recursing. Well, isn't that lovely? Oh my god. Okay, so it's that means it's not correctly tokenizing. So problematic. Give me a second. I'm just going to actually loop this. Well, this bit is doing what it's supposed to do because we are getting the initial splitting. So the tokenizer, right? So this is up to the tokenizer probably. Let's just try this, okay? Tell me S and okay. All right, so the first time it runs fine, and then it doesn't. Okay, so that's not so nice. Oh, I know. I know. Because this needs to be taken care of. Okay, so I'm just going to do a little thing here. So this should be cut token re, and this way I can just interpolate it, no problem. Nice. Else the syntax is a little bit confusing. So yeah. So cut token re. All right. But I mean, you know, oh, damn! I need to capture. I was, I was going to argue with the error message, like, why are you doing this to me? But yeah, right, it was correct. Okay, so now this is curious because it managed to do the initial expansion, but it failed to tokenize. So yeah. Why would that be? I would suppose it has to be the tokenizer, the node, the node side tokenizer. Okay, let's take a look at that. Where did I go wrong? Oh, because it's non-capturing. Okay, there we go. Fixed. I forgot, right, because when you group it like this, it's a non-capturing group. And when you take this out, now it captures. Right, because I don't want, you know, like 10,000 captures. I just want a single one. So, yeah. Okay. So let me just check how long have I been recording. About an hour, so that's fine. Okay, so you can barely see my face, but I can see yours. Just kidding, I can't. What do you think I am? Some kind of a clairvoyant kind of guy? Yeah. Okay. Let's try, see the speed of that without the build. Okay, so it's not quite so fast, but that's fine. Yeah, it does take like a slight second to get it right. So yeah, we still have work to do in here, but you know, a lot of that is because of these queues in here. Okay, so because instead of putting an actual space, I was using the queue modifier. I don't know what to call it, right? But you know, this thing, right? Because I read somewhere that it was good practice, and the problem with that is it creates like a lot of tokens, and so you know we have all of this for a single string, and actually some parts in here are repeats. So this is what. So a lot of this is actually repeat code that should not be there, apparently. Okay, so I will have to look into this because it does seem to me that it is repeating a lot. Like, yeah, like this is wrong. This is obviously wrong. Okay. So, right, so maybe it's because we are a person like that. Nope, that was right. That was correct. Okay. Huh. All right, so apparently something here in the recursion must not be going exactly the way it should. Hey, let's try this. All right, so that was faster, but yeah, we missed a lot of decorations in there. So it means he didn't expand the whole way through. Right? Right. And look at that. It left a lot of comments. So I don't like that. But here you see, this is the expanded scope, right? So here you have it without any processing. So yeah, this whole mambo in here is, yeah, it's like a lot of symbols, and yeah, that is hard to process. It would take a while, obviously. It would always take a while. So yeah, not so nice. Right. Okay, and here is the two declarations that we did get. Right. So the ones outside of the scope that refuses to expand. Well, it does expand, but it refuses to be tokenized properly for some reason. Uh, yeah, I will have to look into this, right? Because it's a quite a long expression and just breaks. So I think that's normal, but you may disagree. That's fine. And this is something I was thinking, like, will the if else be like a single statement? And yes, it is. So that's actually really satisfying to see. Anyhow, one thing I could try, and yeah, I'm not gonna do this right now, but would be, rather than making all of these string tokens like at once, what I could try is maybe join them into a single one. It might not be a good idea, but we don't really have much of an option, I think. This is still something wrong here in the expansion, because I'm pretty sure it's generating more tokens that it ought to. Okay. So, hmm. Hmm. Mm, has something to do with that. Give me a sec. Because maybe, just maybe. All right, now. So let me see this bit. Oh, okay. Right. So what I should do, because, I know, because it's always attempting to tokenize, and so it over tokenized. Right. So it's because this it must be generating additional nodes that are duplicates, right? Because it's the first thing it checks. I should not use the tokenizer as a check. Holy. Okay, yeah, that's my bad. I suppose I coded this up in a hurry or something. Okay. So how can we fix that? Huh. Not entirely sure. Let's see. Because what I'm doing is I'm using the tokenizer as a check, right? So if I have just a single token, then that's that. And if I have more than one, then we actually branch out. So what must be happening is that it must be going through the exact same string twice and creating duplicate nodes out of that. Maybe that's what's happening. I'm not entirely sure. Well, let's try it like this, okay? Let's just forget about this bit. Let's just expand and tokenize. I don't think it's going to entirely work, but let's try. Okay. So, yeah, I'm gonna do that. And this is probably going to infinitely recurse. I'm not sure, but let's try it. Okay. So okay, so it didn't infinitely recurse, and that's good enough for me. Yeah, and it did not expand the whole way through. Oh, so that's not nice, but it's a start. It's a start. Okay, so let's see that cut token 3. It does not begin at the beginning of the string, so nice. Okay. Well, I guess what I could do is just append the node if we happen to be at this stage, we could do is we just put the node back in the queue, right? Not its libs, but the node itself, and see what happens. And what? Where? On the 34. Oh, I missed. Yeah. Infinite recursion. Okay. Oh, right. Next. Go. Nope. Still nothing. Wait, does that mean it's coming in here infinitely? Oh, baby, that's not good. I mean, but if it keeps matching the cut token, that means that it is not properly expanding, or that it expands into an expansible expression. Oh, holy. Oh no, it means I have to flatten the branch. Okay. Easy. Okay, so, but we do have to recurse from the parent, and let's see if that actually makes sense. And yeah, let's just flatten. Okay. Okay, and that seems to work somewhat. But is this part duplicating? Not quite as much. Okay. Or maybe not at all, right? So see, we only have one mention of this, so it might be not duplicating anymore. So mission accomplished. All right, let's take a look at this once again. And okay, here we have our declarations. And yeah, okay, so this time this one is still too long. I don't like it, but it's a little bit better. Let's see about the speed. It's slightly faster, just a hair faster. So that's nice. In here we have a declaration that has nothing, and I don't like that. I don't know why that is happening. So we'll have to preach out the old tree and take a look at that. My. Oh, in here. Oh, because it's right. So the first keyword will become the parent, right? Or like the at the top of the hierarchy in the expression where it first encountered. But if within the same expression you have all the keywords, then we don't really process that right now. So right, so that's where that lone my is coming from. That's not good. That's not good. But what we can do is if we encounter a keyword within a, let's say within a sub expression, right? So let's say this is the expression, and you know all of the childs are like these subs, like this sub expression, right? So any keyword that is not at the top of a hierarchy, right? So it has no children, no branches. What we can do is look at that and say, okay, you know, how many arguments are you supposed to take, right? Something like that. We can try. We can try. Still, this doesn't seem. Oh, right, because it's a right. No. Just forget what I said. It's fine, but it is missing. It is missing the parentheses here. So something went wrong. Because it should be the declaration of the lexical, and then a parenthesized expression, and that parenthesized expression is not present. Let me see. And the same thing has happened with the ifs. So yeah, this is not good. Wonder what's going on here. And oh, and here is the oh no, it's okay, okay. Oh, so it printed the exact same tree twice, and that is no good. Okay, so maybe I am over recursing, I guess. Well, maybe I don't need this. I don't know. Okay. Well, I guess I could just right, because you see here lots of tokens. Because when I flatten the branch, what happens is the root node is deleted and it's replaced by its children in place. And so in order to traverse through those children, I have to go back and look at them. Well, I guess I could save the children before flattening the branch and pushing that into the stack. That might work. Well, not actually pushing, more like unshifting. Yeah. Okay. Okay. Here, right. So we take the leaves before flattening the branch. Let's try that. Maybe it works. And it is deleting the parenthesized expressions, and I don't quite understand why. And oh, look, it thinks that this is a label, and actually I can fix that. So sub tokenize 2. We have to do a negative look ahead here. Okay. We cannot have another one of these or all of these. Okay, let's try that. Oh, I have to rebuild. Okay. So let's see. And there we go. Okay. We will have to sort of actually I do have a regular expression for this. I mean it's trivial, right? Because it's basically a name, a valid name. That's this regular expression right here, followed by two followed by two colons, right? Yeah, that works. But you would have to match this any number of times, right? And then another name, okay? Something like that. Yeah, I mean, we can do that, but I'll see about it later on. For now, this is okay. What does mess with my head is the fact that it's deleting the parenthesized expressions. Like, why is that happening? I don't get it. Could be that. There we go. Oh, yeah. Okay, so it does have this problem, right? So it's not quite so good. But it's a start. I don't like having expressions this long, but it's just what it is. Okay, so that's clearer, at least for me. Let me add some separators in here so I can focus a little bit better. All right. Oh, so the problem here is that we still have some tokens left. So I suppose if right, so I know what. If there's nothing to tokenize, that means we have a single node. The way it happens here, there's no flattening of the branch. But that doesn't necessarily mean that we don't still have another right? How do you say, another token to expand, right? So I guess what we could do in here is go back here, because we essentially need to make the exact same check again for the exact same node. So I mean, I guess I could do this with a while, but then I would have to write this as an if, and I prefer it like this. Because basically, if this is true, then I want this to execute, and if that is not true, then I want this to execute. Even if the condition changes right after the execution of this first block, right? So that's basically if and else. If I do it with a while, it's slightly less clear what I want to do. So fuck you all, I'm going to use goto. Okay, let's see if that helps. And it does. Okay. Problem solved. Goto for the fucking win. Okay, alright. You see? You see? It is useful. You see? You see? Praise goto and use it wisely. That is a peso rule. I'm not joking. Okay, so I'm actually going to show you this. So peso rules dot md and goto. See? See? Praise goto and use it wisely. It is one of the peso rules, and you know it is actually true. You know, goto can be useful. You just need to know when it is wise to use it, and in here it was a good fit. So okay, problem solved. We have a semi-complete way to sort of make a parse tree out of certain bits of Perl code, right? Because I'm only testing this with a single function, so you know it's incomplete, right? So there's corner cases and things I haven't thought of yet. So yeah, this needs more work. Obviously, I should keep working on this, and obviously I should fix this situation with the 1,000 tokens for like you know, like a single thing that doesn't make any sense. I don't like it. So yeah, we have some work to do. We have some work to do. That's fine. And yeah, I think we're done here, right? I'm just gonna go to sleep, I guess. Anyhow, that's it from me. Have a good one. Bye.